Hello everyone, you're welcome back to this channel. In this video, you're going to solve this question I have here on the board. The question says a 100 pounds force acts as shown on a 300 pounds block on an inclined plane. The coefficients of friction between the block and the plane are given as that the coefficient of static friction is 0.25 and that of kinetic friction is 0.20. Determine whether the block is in equilibrium and find the value of the friction force. So let's look at how we are going to go about this question. So I will start by drawing a free body diagram for this figure that has been given to us. Okay, so let's look at that. So I'm going to draw the block on the inclined plane. Okay, so that's the block. So now let's indicate the forces that will be acting on the block. So we are going to have the weight force. Okay, the weight force, which is the 300 pounds. Okay, and then we're going to have what? A normal force, and this normal force will be what? Perpendicular to the inclined plane. Okay, so it's going to be something like this. So this will be the direction for the normal force, right? So if you indicate it, you are going to have the normal force to be here. So this will be the normal force. Okay, so now it's left with this applied force here. Okay, so that's also in this direction here. Okay, and then we are going to have the friction force between the two surfaces in contact. So let's name it as what? F. Okay, so this is what you are going to have. Okay, so right now what you are going to do is that let's look at our x and y axis. Okay, so I'm going to consider this axis as my x axis. Okay, and then this will be my y axis. Okay, so you can see that the applied force, which is the 100 pounds, okay, is being applied in the x-axis direction. Okay, and then the normal force, okay, is in the y-axis direction, which is what perpendicular to the plane. But you see that the weight force of the block, okay, is making an angle. Let's name that angle your theta. Okay, with the y-axis. Okay, so we are going to talk about that angle for now. Okay, so because this weight force is making an angle with the y-axis, it's going to have two components, right? One in the y-axis direction and then one in the x-axis direction, right? We're going to have, let's name it wy and then wx. Okay, so we're going to have something like this. Okay, so now what you're going to do next is that you're going to what? Find the component of what? The weight force, right? That the block is exerting on the what? Surface, right? But before you can do that, you must know the value of what? This theta here, right? Okay, so let's look at something here. We have this inclined plane here, and then we've been given 5, 4, 3 here. That's this small triangle here. Okay, so let's say this angle is what? Theta. So that would be the same angle that we will have for this small triangle here. Okay, let's take note of that. Okay, so if you find the theta here, that's the same theta that you're going to be having here. Okay, the same for this point here. Okay, let me explain the reason why we have that to you. So let's say we have an inclined plane here. Okay, and this is what? Our theta. Okay, you have this to be our normal force, and then this is what? The weight force. Okay, and then we'll have our x-axis here. Okay, and then our y-axis here. Okay, so this is what? The theta that I was talking about. Okay, so right now let's take it out. You don't have it there. So if I draw a horizontal line through this center here, you know you're going to have here to be what? Theta, right? Okay, so if here is theta, here will also be what? Theta, right? Directly opposite. Okay, all right. So we know that this angle here should give us what? 90 degrees, right? Okay, right. So we have theta here at 1. So here what? 90 minus what? Theta. Okay, so you have something like that there. Okay, so over here, you are going to have what? 90 minus what? Theta here, right? Okay, so now let's name this angle here as what? Alpha. And let's find this angle. So over here, the weight force, okay, will make an angle of what 90 degrees with what this horizontal line that I've drawn here, right? So when you sum these two angles, we should get what 90 degrees, right? So we are going to have this angle here, alpha plus 90 minus what theta. That should give us what 90, right? So we are going to have alpha minus theta equals what 90 minus what 90. That would be what 0. So we're going to have what alpha to be equal to what theta, right? So that means you can come and write what theta here. Okay, so that's how come we have theta here. Okay, all right. So now we understand why we have theta here, right? Okay, so now let's take cosine of what this theta here. This is our 3, this is our 4, and then this is our 5, right? So cosine of what theta, right, will be equal to what the adjacent side over what the hypotenuse, right? Okay. All right, so now cosine of theta, we have the adjacent side here, then have the hypotenuse to be 5, right? And then sine of theta we equal to the opposite side over the hypotenuse, right? So let's consider what you have here. Okay, let's take cosine of what theta here, right? So the cosine of theta there, okay, cosine of theta for this side will be equal to what the adjacent, right? Which is this. So wy over the hypotenuse, which is what the 300, right? So we're going to have wy to be equal to what 300 cosine of what theta, right? But we know cosine of theta to be what 4 on 5. So we're going to have multiplying was 4 on 5. Okay, and then we know it is what pointing downwards, right? So that's negative. Let's take note of that. Let's do same for ws. So for ws, we're going to have 300 multiplying with sine of what theta, right? But we know sine theta is what 3 on 5. So we're going to have ws to be equal to 300 multiplying what 3 on what 5. Okay, all right. So now this will be the y component of the weight force. And this will be the S component of what? The weight force. Okay, they are really important. We have to find them. Okay, so now let me clean this so that we can continue. Okay, now the question is, we should determine whether the block is in what? Equilibrium. Okay, so how are we going to know if the block is in what? Equilibrium. So let's consider the forces in the X axis direction and the forces in the Y axis direction. Okay, so considering the forces in the X axis direction, we have this force, we have the friction force, and then we have the components of the weight force in the X axis direction, right? So before this system will be in equilibrium, when you sum up all these forces in the X axis direction, it must be equal to what? 0. And then this normal force should be able to balance the Y component of what? The weight force, right? So you're going to have sum of forces in the X axis direction to be equal to what? The 100 pounds, right? Minus the friction force. Okay, minus the friction force. Okay, minus the S component of what? The weight force, right? So that's what? Minus 300, okay, multiplying 3 on 5. Okay, so this should be equal to what? 0, right? So let's find the value of what? F. So we're going to have 100 minus 300 multiplying 3 on 5. So this will give us minus F minus what? 80 equals what? 0. We're going to have minus F equals what? 80, and then F will equal to what? Minus what? 80. Okay. So that means that before this system will be in equilibrium, okay, before the S forces can balance each other, this friction force, okay, must be what? 8. Okay, so now let's look at something here. When we calculate for the S component of this weight force here, which is what? 300, okay, times what? 3 on 5. When you calculate this, let's see what you're going to get. 300 times 3 on 5, it gives us a value of what? 100 and what? 80 pounds, right? Okay, and this force, this is that force, right? So let's look at that. The applied force is going in this direction, okay, and that's what 100 pounds, and then the S component of the weight force is in this direction, which is what 180 pounds, right? So you see that already the Y component, the X component of the weight force is bigger than this, right? Before you'll be able to balance this, we must have another force, which is what the friction force, and that friction force must also act in this direction, right? It must also act in this direction, so that's what when we add this and this, you get what 180, and then this is what also 180, but they're in the opposite direction. Okay, so F will actually be in what in this direction. In other words, for this block to be what to be balanced. Okay, so we are going to have F to be actually 80 pounds, right? And it should be pointing in the what positive x axis direction, so that's what it will be able to what balance this. Okay, when we add it to this value. Okay, but this guy is already pointing here, and it's what 180, and then this one is pointing in this direction, it is what 100. Okay, so if you point the friction force in this direction, it can balance the 180 here. Okay, so that because that was 100 minus what 80, and then that'll give us what 20, and then that 20 can't balance it, so the friction must move in this direction. Okay, so that's why we have what 80 pounds, and we have the direction in that way. Okay, so what that means is that before this system will be in equilibrium, okay, before this system will be in equilibrium, okay, the friction force, okay, in the x-axis direction might be equal to what 80 pounds. Okay, so let's consider the forces in the y-axis direction. So for that one also, you have the normal force, which is positive, minus what the y component of force, the weight force. So that's what minus what 300 multiplying cosine of what theta, and that's what 4 and 5. Right. So let's see what we are going to get. This is going to give us a value of what 240 pounds. Okay. So now for this system to be in equilibrium, the normal force must be 240 pounds, and then the friction force must also be what 80 pounds, and then this must go in this direction, and then the normal force must also go in this what direction. Now the direction of what the positive y-axis. Okay, for equilibrium to be maintained. Okay, so now what you are going to do next is that you're going to determine whether the block is not equilibrium or not. Right. So let's look at how we are going to do that. So what condition are you going to use to tell whether the block is in equilibrium or it is what sliding? Okay, so let's look at how you are going to detect that. For us to know whether the block will be in equilibrium or will be sliding, what you have to do is that you have to find the maximum friction which will be generated between the block and then the surface, and then compare it to what the friction force that we need what to maintain what equilibrium. If that value is equal to that friction force, then that means what equilibrium will be what maintained. But if it is less, that means what there will be what no equilibrium, which means the block will be sliding down. So now let's find the actual maximum friction that will be here. Okay, that will be what will be here when you consider what this figure here. So we are going to have Fm to be equal to the coefficient of what static friction, because we are considering equilibrium. So we are going to use coefficient of what static friction times what the normal force, right? So we know the coefficient of static friction to be what 0.25, right? And then you know the normal force to what 240 times what 240. So we are going to have 0.25 times what 240. So that gives us the maximum friction force to go with 60 pounds. Okay, so let's look at something here. We need 80 pounds for this system to be in equilibrium, otherwise what the block will slide. But now let's find out that the maximum friction, okay, that will be present as a result of what the surface of the block and then the inclined plane being in contact is actually what 60, which is not equal to what the friction force that we need for the equilibrium to be maintained. Okay, so because this value here is less than what we need to maintain equilibrium, the block is going to what slide. Okay, so look at something here. It's like we have 100 pounds here, and then we have what 50 pounds here, right? If we add this to this, okay, that was 160, right? And then that cannot balance what the 180 pounds force that we have here. So because of that, the block will slide downwards in this direction. Okay, so due to that, the block will not be in equilibrium. Okay, so that means what we've answered this part. Determine whether the block is in equilibrium, right? You've answered this part. So now let's find the value of what the friction force. So right now we that the block is not in equilibrium. That means what it is sliding, right? So if it is sliding, what will happen? There's going to be another friction, okay, which was tries to resist what the sliding motion, and that friction is known as what the kinetic friction. So that's the friction that you find now, since the block is what sliding. So you are going to have that friction to be equal to the coefficient of what kinetic friction times what the normal force, right? And this value was given to us as what 0.2. So times the normal force times what 240. So that what 0.2 times what 240. This will give us a value of what 48 pounds. So that means that now that the block is sliding, the friction force that is going to be present will be what? This 48 pounds that we have here. Okay, so that's how to go about this kind of question. Thank you very much for watching this video. Please, if you haven't subscribed to this channel, kindly make sure you subscribe and like the video. Thank you.